In this lesson, you will learn how to simplify radicals with variables. First, let's review how to simplify a radical with no variables, and then we'll get into simplifying radicals with variables. Recall how to simplify a non-perfect square like the square root of 8. If you remember from a previous lesson, to simplify the square root of 8, you will first create a factor tree to find the prime factors of 8. So thinking of the prime numbers, which would start with 2, 3, 5, and then 7, you want to break the 8 down into two factors whose product is 8. One of them should be a prime number. So let's start with 2 and 4. Then circle the prime number, and any number that's not a prime number needs to be further broken down using the prime numbers. So 4 can be broken down into 2 times 2, which are both prime numbers. Once it's broken down into all prime numbers, write it out and then underline any pairs of the same numbers and multiply those together. So this would be 4, and then drop down any number that's not a prime number, not part of a pair. Transfer that up here because this tells us that the square root of 8 breaks down into the square root of 4 times the square root of 2. The perfect square we then calculate, so the square root of 4 is 2, and the non-perfect square we leave under the radical. So 2 radical 2 would be the simplified version of radical 8. Let's do one more of these. The square root of 108. So because it's not a perfect square, we're going to break it down into its prime factors. We can start with 2. So 108 divided by 2 is 54. Circle the 2 because it's a prime number. Then we will break down 54. 2 goes into 54 27 times. 27 can then be broken down into 3 and 9, and 9 into 3 and 3. So our prime numbers are 2 times 2 times 3 times 3 times 3. Again, underline any pairs of prime numbers and multiply them together. Drop down any number that's not a perfect square. Going back up here, the square root of 108 then breaks down into the square root of 4 times the square root of 9 times the square root of 3. The numbers that are perfect squares, we will go ahead and simplify to 2 and 3. We then multiply those together, giving us 6. The square root that cannot be simplified will simply drop down. So the square root of 108 is 6 radical 3. Now let's move to variables. Now hopefully you've been exposed to the square root of a variable if its exponent is an even number. To take the square root of a variable, if it's an even number, you simply divide it by 2. So in this case, 2 divided by 2 is 1. Therefore, the square root of x squared is just x to the first, or x. If you look at the second example, the square root of x to the 8th, again, just divide it by 2. So the square root of x to the 8th equals x to the 4th. This is because x to the 4th times x to the 4th equals x to the 8th. Recalling that square root means find the number, in this case the variable, times itself. That gives you the number or variable under the radical. Now what would happen if the exponents were not even numbers? If they are not even numbers, then any remaining x will have to stay under the radical. What I mean is this: you will approach this in a similar way that you do the numbers, except for you don't have to break these down, obviously, into their prime factors. So the square root of x cubed is the same as x times x times x. Basically what you do is find or underline a pair of x's, because this is the same as x squared times x. Now remember, if the exponent is an even number, then you can simply divide it by 2, which means it's a perfect square. So if you divide 2 by 2, this particular x squared will come out to the outside, leaving us with x. The x that has an exponent of 1 will remain under the radical. So the square root of x cubed simplifies to x radical x. Let's look at an additional example. The square root of x to the 5th is x times x times x times x times x. Now, it's a little bit different with variables. A shortcut is to simply underline as many x's that you can, but ensure that you have an even number for the exponent. So I would want to underline 4 because 4 is an even number. So you will always, with variables, if it's an odd exponent, you should always have one variable left over. So then the one with the even numbered exponent, you can simply divide the exponent by 2 to simplify that square root. And then you should have a single variable left under the radical sign. What about if we have multiple variables? Well, again, just treat each variable separately. So start in this example with x cubed. So this would be 3 x's, and then we have a y. Now, the most x's I can underline to have an even numbered exponent would be x squared. And then I have the y. Now, x squared is a perfect square, but x and y are not. So I will only take the square root of the x squared, which is just x, because I divide the exponent by 2, and the other x and y remain under the radical symbol. In this next example, we have 5 x's and 4 y's. So again, underline as many as you can so the exponent is an even number. So we have x to the 4th. We have 1x left. With the y's, we only have 4, so all the y's make up our perfect square with none left over. Now we will take the square root of x to the 4th and y to the 4th by dividing both of their exponents by 2, leaving us with x squared, y squared. And then we have an x left under the radical symbol. So our answer is x squared, y squared, radical x. What if we have 3 variables? The same thing happens. So we're going to write out each variable and treat each one separately. We have 7 x's, 3 y's, and 4 z's. So I'm going to underline 6 x's, so I have x to the 6th, and I have 1 x left over. For the y's, I'm going to underline 2, because again, I want its exponent to be an even number, and I have 1 y left over. And for the z's, I can underline them all, and there will be none left over. Looking at the perfect squares, x to the 6th, y squared, and z to the 4th, if I take their square roots by dividing their exponents by 2, that leaves me with x cubed, y, z squared, which will go on the outside of the radical symbol. Inside will be the variables that are not perfect squares. So I have 1x and 1y. Lastly, what if I have numbers and variables? Again, you need to treat each one separately. I would probably start with the 20 and go ahead and create a factor tree and break it down into its prime factors. So we have 2 and 10 and 2 and 5, which gives us 2 times 2 times 5. Underline your pairs of prime numbers and multiply them together. So 20 breaks down into 4 and 5, 4 being the perfect square. X to the 5th, if you've got 5 x's, you underline as many as you can so that its exponent is an even number. So that would be x to the 4th with an x left over. The y has an exponent of 1, so we cannot break that down at all. The z has 9, so we should be able to break that down into 8 z's with 1 left over. Now our perfect squares are going to be 4, x to the 4th, and z to the 8th. So let's simplify those first because those will go on the outside of the radical. The square root of 4 is 2. We'll cross that out because that's complete. The square root of x to the 4th, if we divide the exponent by 2, is x squared. And the square root of z to the 8th, if we divide that by 2, is z to the 4th. So that is what goes on the outside of the radical. Then we have radical 5, radical x, radical y, and radical z. None of those are perfect squares, so we will just put them all together under the radical symbol. And that completes the lesson on simplifying radicals with variables.